Problems on trains are a crucial and often scoring topic in competitive exams, falling under the broader category of speed, time, and distance. Many students find them challenging due to factors like a train's inherent length, its relative motion to other objects, and how effective speed changes based on direction. To master these problems, three core ideas must be understood: train length, the total distance to be covered, and relative speed. This guide covers all essential formulas, concepts, shortcuts, cases, and tips, making it the perfect one stop resource for competitive exams. First, let's look at speed conversion formulas, which are the first step in solving any train problem. To convert kilometers per hour to meters per second, you multiply the speed by 5/18. Conversely, to convert meters per second to kilometers per hour, you multiply the speed by 18 fifths. These conversions are crucial because trains move large distances in short times, making meters per second more accurate, and mixing units leads to wrong answers. Next, we have the basic speed, time, and distance formulas, which are the foundation of all train problems. Remember, speed equals distance divided by time equals distance divided by speed, and distance equals speed multiplied by time. These apply everywhere, from poles and platforms to overtaking and meeting point problems. When a train passes a pole or a man, which are considered zero-length objects, the train only needs to cover its own length. The formula for time taken is simply the train's length divided by its actual speed. However, when a train passes a platform, bridge, or tunnel, the object has length, so the total distance is the train's length plus the object's length. In this case, the time to cross is the sum of the train and platform lengths divided by the train speed. Now, let's delve into relative speed, which is essential when two trains are involved. When two trains move in opposite directions, they close the distance faster, so their speeds add up to form the relative speed. The total distance to be crossed is the sum of both train lengths, and the crossing time is this total distance divided by the combined speeds. Conversely, when two trains travel in the same direction, the faster train must catch up, so the effective speed is the difference between their speeds. The crossing time in this scenario is the sum of their lengths divided by the difference in their speeds. A useful shortcut for meeting point questions is the speed ratio formula after meeting. If two trains meet and then reach their destinations in times and B respectively, then the speed of train A to train B is B2. This works because after meeting, the trains travel remaining distances and speed becomes inversely proportional to the remaining time. To master these problems, always convert speed into correct units first, typically meters per second. Identify the exact distance the train must cover: L for a pole, L plus B for a platform, and A plus B for two trains. Always use relative speed for moving trains, adding speeds for opposite directions and subtracting for the same direction. Drawing a simple line diagram can prevent most conceptual mistakes by helping you visualize the trains as blocks with lengths and directions. Focus on patterns instead of memorizing formulas, as most questions follow repeated scenarios like crossing a pole or a platform. Double-check lengths before calculating, remembering that length equals distance in train problems. Finally, practice typical exam patterns from various competitive exams to increase familiarity and reduce time per question. Mastering problems on trains boosts your conceptual clarity in all speed distance topics, improving your overall quantitative ability for competitive exams.